Hi, welcome to Math After Hours with Miss Austin. I'm Miss Austin, a licensed math teacher here to help you with any of your math problems. Today I'm going to show you how to find the inverse of a 3 by 3 matrix. The main use of the inverse is with solving a system of equations. So you may be doing that in the future in one of your classes, but today I'm just going to show you how to find the inverse. A matrix has an inverse if the determinant is not 0. So a matrix will be singular and have no inverse if the determinant is 0. The matrix that I have chosen today has a non-zero determinant, so we are good to go ahead and find the inverse. If you want to know how to find the determinant of a 3 by 3 matrix, I have a video for that on my channel. So the way we find an inverse of a 3 by 3 matrix is we first set it up with our matrix A on the left-hand side, and we put the identity matrix on the right-hand side. The identity matrix has ones along the diagonal and zeros everywhere else. The goal is to turn the left-hand side into the identity matrix, and then our inverse will end up showing up on the right-hand side. So there's a little bit of a pattern in which you need to go in to convert the left-hand side into the inverse. Now you'll notice if we compare the two, we have a 1 right here in the top left, and that's what we want. We want a 1 in the top left because that's what the identity has. So that's nice. So the next thing I'm going to do is take care of the numbers right below it. We want to get rid of the two negative ones. So specifically, I'm going to start with this one right here. So we're going to use row operations to turn the left-hand side into the identity. So what kind of row operation could I do to turn this number right here into a 0? Well, you want to think about what you would do solving with elimination a system of equations. We usually multiply one equation by something because we want to add the two together to get a variable to cancel out. So if you look at the first two rows right now, we have a positive 1 right above it. So what if we added the first two rows together? So I'm going to say row 1 plus row 2. And this is specifically to change row 2. We are not changing any of the other rows right now. So that means when I rewrite this matrix, row 1 is staying the same. So I can fill that in. Row 3 is also staying the same. I'm not changing that. But to get row 2, we're going to add the rows together right here. So 1 and negative 1 gives us 0. 0 and 2 gives us 2. 2 plus 3 gives us 5. 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 0 is 0. Okay, so we are one step closer. We have our 1 and our 0 in the right place. The next place we want to go is right here. We want to turn this one into a 0. So I can use row 1 again, but now just add it to row 3 and change row 3. So usually you end up using row 1 in the beginning to get those first two zeros in the second row and the third row. So when I build this matrix, now we are changing row 3. So row 1 will not change. I can fill that in. Row 2 will not change, so that one's 0, 2, 5, 1, 1, 0. And then to get the third row, we're going to look at the previous matrix and add the terms in rows 1 and 3 together. So 1 and negative 1 is 0. 0 and 1 is 1. 2 and 0 is 2. 1 and 0 is 1. 0 and 0 is 0. 0 and 1 is 1. So now we have the first column as what we want it to be. We have 1, 0, 0 in that first column. The next number you are going to go to is right here. We want this to be a 1. Now, if you watched my video on how to find the inverse of a 2 by 2 matrix, it worked out to just divide by a number to get that to be a 1. In this case, that's not going to work because if we divide this whole row by 2, we're going to end up with fractions. That is not something we want to do if we don't have to. So instead, we're going to use subtraction. Now, at this point, you have to use rows 2 and 3 together. Because if you're going to be adding rows together, if you add row 1, you're going to undo the 2 zeros that you just got, which is not something you want to do. We don't want to go backwards. So we're going to use some sort of combination of rows 2 and 3. So how could I use these two numbers right here to get a 1? Well, 2 minus 1 is 1. So what if we just do row 2 minus row 3 to change row 2? The first row, still haven't changed that. That stays the same. We're not changing row 3 on this one. And then for row 2, we're going to do row 2 minus row 3. So 0 minus 0 is 0. 2 minus 1 is 1. 5 minus 2 is 3. 1 minus 1 is 0. 1 minus 0 is 1. 0 minus 1 is negative 1. Okay, so we're getting closer. All of these elements right here are what we want them to be, those ones that I've just highlighted in yellow. The next number we want to change is this one right here. We want that to be a 0 in order for it to turn into the identity. And we have to use row 2 to help us, because if we use row 1, we'll undo some of those zeros. So I want to do some sort of combination of rows 2 and 3 to make that a 0. But if you look at the element right above it, that's also a 1. And 1 minus 1 is 0. So that's nice for us, because if we do row 2 minus row 3 to change row 3 now, we will get that 0 that we need. So rows 1 and 2 are not going to change. We will have 1, 0, 2, 1, 0, 0. We will have 0, 1, 3, 0, 1, negative 1. So for this new row 3, we're going to do 0 minus 0, which is 0. 1 minus 1, which is 0. 3 minus 2, which is 1. 0 minus 1, which is negative 1. 1 minus 0, which is 1. Negative 1 minus 1, which is negative 2. What's really nice at this step is we got a bonus, because when we got this last 0, we also got this 1 in the bottom right-hand corner. So that saved us an extra step, because now we don't have to put that 1 there. It's already there, which is nice, because this process takes a really long time. You're probably already getting tired. So stick with me, because we're almost done. We've gotten the majority of the places done. Okay, the next number we are going to go to is this one right here. We want this 3 to be a 0. So if I want that to be a 0, row 3 might be nice to use because these zeros are already in place, and so it's not going to change anything else. I can just use this 1. And we can multiply the entire row 3 by anything we want if we're changing row 2. So what if I did row 2 plus negative 3 times that third row? Because then I'd have a 3 plus negative 3, which is 0. And this is going to change row 2. So row 1 is still 1, 0, 2, 1, 0, 0. Row 3 is done. That one's not changing. And then I'll write these numbers off to the side. So we're going to have row 2. Those numbers are 0, 1, 3, 0, 1, negative 1. And then if I multiply row 3 by negative 3, that's 0, 0, negative 3, 3, negative 3, 6. So adding these together will give me my new second row. That's 0, 1, 0, 3, negative 2, 5. So here's 0, 1, 0, 3, negative 2, 5. Usually when I'm multiplying a row by something, I'll actually do the math off to the side because I'm more likely to make a mistake if I don't. My students always try to skip that step and then they get it wrong, which sucks because when you're doing a question like this, if you make a little mistake, it just carries through the rest of it. So if you can show your work more, you're less likely to make a mistake. Okay, so we have all of these numbers in place. So the only thing we have left to fix is the first row. So you're going to start with this element here. You want this 2 to become a 0. Now, which row do you want to help you on that one? Well, you can't use row 2 because right below that you have a 0. And when we multiply a 0 by something, it will stay 0. But row 3 could help us. If we leave row 1 alone, but we multiply the third row by a negative 2, then we can change that first row. So those elements will be 1, 0, 2, 1, 0, 0, and then I'm multiplying the third row by a negative 2. That's 0, 0, negative 2, 2, negative 2, 4. So that gives me 1, 0, 0, 3, negative 2, 4. So that is my new first row. So that's 1, 0, 0, 3, negative 2, 4. I didn't change the second row, and I did not change the third row. And look at that. That step actually gave us this last 0 we needed as well. So we have that identity on the left-hand side, and our inverse matrix is right here on the right. So A inverse is 3, negative 2, 4, 3, negative 2, 5, negative 1, 1, negative 2. And that is how you find the inverse for a 3 by 3 matrix. It does take a little bit of time, but you'll notice it tends to be simple arithmetic once you know the pattern of how to find things. You're mostly just multiplying and adding numbers together. So the more work you can show, the less likely you are to make a mistake. Thank you for watching. Thank you for sticking with me. If you have a video you would like me to do, please comment below, and please like and subscribe.